Spectrophotometry and NanoDrop. What is spectrophotometry? Spectrophotometry is a technique used to measure how much light a chemical substance absorbs. It is widely used in molecular biology to determine the concentration and purity of nucleic acids, DNA, RNA, and proteins in a sample. Basic principle: every molecule absorbs light at a specific wavelength. The amount of light absorbed is proportional to the concentration of the molecule. Beer-Lambert law. Equals epsilon dot operator C dot operator L. A equals epsilon dot operator C dot operator L, where A equals absorbance, epsilon equals molar absorptivity, C equals concentration, L equals path length. Types of spectrophotometers. 1. UV vis spectrophotometer measures absorbance in the UV visible range, 200–800 nanometers. Requires 1 milliliter or more sample in a cuvette. 2. NanoDrop spectrophotometer, micro-volume spectrophotometer. Requires only 1 to 2 microliters of sample. No cuvettes needed. Uses surface tension to hold sample. NanoDrop overview. NanoDrop is a brand of micro-volume spectrophotometers designed for quick and accurate quantification of nucleic acids and proteins. Advantages: only 1 microliter of sample needed, no dilutions required, fast results within seconds. Measures concentration and purity ratios, wavelengths for nucleic acids and proteins. Molecule peak absorbance, NM. Notes: DNA 260 nanometers indicates nucleic acid content, RNA 260 nanometers same as DNA, proteins 280 nanometers due to aromatic amino acids, TRP, TIR, contaminants 230 nanometers, phenol, salts, organic. Purity ratios. NanoDrop or UV vis. Ratio ideal value interpretation A260, A280 to 1.8, DNA. Approximately 2.0, RNA. Lower equals protein contamination. A260, A230 to 2.0 minus 2.2 lower equals salt, phenol, or solvent contamination. Applications. Measuring DNA, RNA concentration before PCR, cloning, or sequencing. Verifying RNA purity before RT-PCR or RNA-seq. Quantifying protein samples for Western blot or ELISA. Assessing sample degradation or contamination. Steps to use NanoDrop. Open lid and initialize instrument. Blank with nuclease-free water or buffer. Load 1 microliter of sample onto pedestal. Lower arm and start measurement. Record concentration and purity ratios. Limitations: does not distinguish between DNA and RNA. Cannot assess fragment size or integrity, use gel for that. High contaminants can skew purity ratios. Comparison: NanoDrop versus traditional spectrophotometer. Feature: NanoDrop traditional spectrophotometer, sample volume 1–2 microliters to 1 milliliter, speed fast, seconds, slower sample recovery, not recoverable accuracy high for clean samples, reliable but needs more volume, visual interface, digital touch display, manual or digital.